All right, in this example, we're going to go over the application problem for systems of inequalities. So this is the last problem on the first worksheet you have in your notes already. So we'll go through this together. This one's talking about a pet store. Sarah's pet store never has more than a combined total of 16 cats and dogs. So 16 cats and dogs, and they never have more than that total. She also never has more than 9 cats. She never has more than 9 cats. Write a system of linear inequalities and graph to show the number of cats and dogs at her store. So this is going to be similar to when we were doing systems of equations using real-world applications, but this time instead of it being equations, it'll be inequalities. So we have two situations going on. At the pet store, they never have more than a combined total of 16 cats and dogs. So remember, the first step is to always define your variables. So we're comparing cats and dogs. So let's say that X means cats, it's the number of cats, and Y represents the number of dogs at the pet store. Okay. Now let's write our first inequality. Sarah's pet store never has more than a combined total of 16 cats and dogs. So when I see combined total, I should be thinking addition. So the number of cats plus the number of dogs has never been more than 16. So it can't be more than 16. It's got to be less than or equal to 16. It has never been more than 16. So when they're saying that phrasing, could it equal 16? Yeah, it just can't be more than that. So less than or equal to 16. So that is our first equation that we're going to use, our first inequality. Then they also say she never has more than 9 cats. So since we're talking about cats, this one's just going to be an X inequality. She never has more than 9 cats. So it's not X is greater than 9, it's less than 9. She never has more than 9 cats, so could she have exactly 9 cats and that be true? Yeah, because she could have 9, she just can't have more than that. So X is less than or equal to 9. So we have our two inequalities, and now we can graph them on our coordinate plane. So let's graph the first one. X plus Y equals 16, or is less than or equal to 16. Well, we can't just graph it like that. We've got to move it out of standard form. So I'm going to subtract X, and we're left with Y is less than or equal to negative X plus 16. So now that's in Y equals mx plus b form. So we can graph that more easily. So it's got a y-intercept of 16. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let me just count that again. Okay. And then it's got a slope of negative 1 over 1. So down 1 over 1, down 1 over 1. We're going to continue this pattern. And then we're going to take our ruler, make a nice line. And so if you're doing this, just make sure that that ruler is lining up on all those intersections. Okay. And this is a solid line. All right. So we've got a solid line. Now it says Y is less than or equal to that. So that means we're going to shade below the line. I should also have labeled my X and Y axis. Okay. All right, so we've got the first one. Now let's go ahead and graph X is less than or equal to 9. Whenever I see something that's not in Y equals mx plus b form, it's usually X or Y equals. So I always think of Hoivux. That's how I remember these special cases. And X is a part of Vux, which means vertical. So a vertical line is X equals, or X less than, X greater than, whatever. So we're going to draw a vertical line at X equals 9. So let's count out 2, 3, 4, 5, 6, 7, 8, 9. Is less than or equal to 9. So it's a vertical line at 9. And since it's less than or equal to, not just less than, it's going to be a solid line. and they say x is less than or equal to. So we're going to shade, we can't really shade above or below because it's a vertical line. We shade where the values are less than 9. So the x values that are less than 9 are to the left of this line. So we're going to shade everything to the left of this line. So this overlapping section right here are all the possible solutions of the number of cats and dogs that they can have. So for example, if there's a point on here, let's say this point, what does that mean in the application? Well, x represents cats, so this axis is cats, and y is dogs, so the vertical axis is dogs. So what is this point? It's 4, 5. So that means that it's possible that the shop has 4 cats and 5 dogs. So any point within this overlapping shaded region represents the number of cats and dogs that Sarah's Pet Store could have at any one time.